Alright, so let's review some of these arithmetic sequence and series problems. Okay, so let's take a look at this one here. So we have this arithmetic sequence, right? And part A says they want us to write down the first term, right? So the first term we know is 11. So that's easy. The first term is 11. And they want us to find the common difference. So the common difference, that's when we subtract consecutive terms. We have 15 minus 11, so that's going to give us 4. Okay. Part B, we need to find the 101th term. So I'm going to use the nth term formula, right? So the formula says I take the first term plus n, which is 101, minus 1 times d, which we know is 4. So you put all this in the calculator. It turns out there's going to be 411. Okay? And then we also need to find the sum of the 101 terms. So if you need to find the sum of the 101 term, right? Well, remember there's two versions of the sum formula, right? So we have one version of the sum formula for arithmetic sequence is n divided by 2 times the first term plus the last term. So whenever you know the last term of the sequence that you're trying to find the sum of, you would use this version of the formula. Now if you don't know the last term, you can also find the sum using this version of the formula, n over 2 times u sub 1 plus n minus 1 times d. So if you do not know the last term of the arithmetic sequence that you're trying to find the sum of, you want to use this version of the formula. If you do know the last term, you want to use this version of the formula. Okay? So in this case, since we know the first term is 11 and the last term in this case is 411, we're going to use this version of the formula, right? So the sum of the first 101 terms is going to be 101 divided by 2 times the first term 11 plus the last term in this case, which is 411, right? So we put all this in the calculator and we're going to end up with, I believe, 21, 3, 11. Okay? Alright, so let's take a look at part C now. So part C says find the sum of the first 20 terms. So we want to find the sum of just the first 20 terms. Now since we don't know the 20th term, we don't know the last term in this sequence. So I'm going to use this other version of the sum formula. So the sum of the first 20 terms will equal 20 divided by 2 times 2 times the first term, which is 11, plus n, which in this case is 20, minus 1 times d, which we know is 4. Okay? So we're going to put all this in the calculator, calculate this, so it doesn't turn out, we're going to end up with 980. Alright, so let's take a look at D. So D, we need to find the general term formula, right? And they want us to express it in this form. Okay? Let me get some space real quick. So D, so the general term formula, u sub n, is equal to the first term, which we know is 11, plus n minus 1 times d, which we know is 4. So typically you want to simplify this, so you want to distribute that 4. We get 4n minus 4, right? So we would get 4n plus 7. This would be the general term formula in the form that they want right there. Okay? And then part E, they want us to find the value of n, given that u sub n is 51. Okay? So that means 51 is going to equal, and then go ahead and use this nth term formula. Alright, 4n plus 7. So we minus 7, we get 44 is equal to 4n. So we know n is going to equal 11. Okay? Alright, let's take a look at this next problem here. So it says the second term of an arithmetic sequence is 7. So we know the second term is equal to 7. The sum of the first 4 terms of the arithmetic sequence is 12. So we know the sum of the first 4 terms is equal to 12. We need to find the first term and the common difference. Right? So if we know this is the sum, right? Let's use the sum formula and write the equation. Now we have 12 is equal to, this is the fourth all right, 4 terms, so it'll be 4 divided by 2 times 2 times the first term. Right now we don't know the first term. You could just write u sub 1 plus, and then we have n, which in this case is 4, right, minus 1 times d. Okay, so using this information, we're able to write this equation out using the sum equation, right, sum formula. Same thing we're going to do here. If this is the second term, I'm going to use the nth term formula, which says, well, the nth term, in this case, the second term is equal to 7, so 7 is going to equal the first term plus, and then we have n, in this case n is 2, minus 1 times d. So we're going to end up with u sub 1, right, plus d is equal to, right, 7. So if you get u sub 1 by itself, so 7 minus d is equal to u sub 1. Because what we're going to do now is we're going to take this, we're going to substitute it into the other equation right here. We're going to substitute it for u sub 1. So that way we get everything in terms of d, so we can solve for the common difference. So we're going to end up with 12 is equal to, 4 divided by 2 is 2. We have 2 times 7 minus d plus, and we get 3d, right? So we're in here, we're going to end up with 14 minus 2d plus 3d, right? So we're going to end up with right here 14 plus d times this 2 on the outside, or actually we could just divide by the 2, so we can make this equal to 6. 6 is equal to 14 plus d, so minus 14 on both sides. So we know our common difference is going to be negative 8. So now that we know what our d is, the common difference, we can substitute into here to find the first term. So 7 minus negative 8 is equal to the first term. So negative becomes positive, so we know the first term is going to be 15. Okay? Alright, so let's take a look at this next example here. So we have an arithmetic sequence, right? It says the first, second, and third term, right? And it has d is equal to 11, and the 27th term is 263. So part A says we need to find the first term, okay? Well, we're going to use this information right here. So we know the 27th term is 263. So 263 is going to equal, well, whatever the first term is, plus n, in this case it would be 27, minus 1 times d, which they gave us is 11. So you work this out, basically this is going to be 26 times 11, right? So you have u sub 1 plus 26 times 11, that gives us 286 is equal to 263, and then subtract 286 on the other side. So it looks like that's going to give us negative 23. Alright, so we've got the first term here. Alright, so let's take a look at B1 here. So we know the nth term is 516, and we need to find the value of n. Okay, so we have 516 is equal to, and then over here we have the first term, which we calculated earlier, which is negative 23, plus n, which we don't know, minus 1 times d, which they gave us, is 11. So we're going to work this out. This will give us 11n minus 11, negative 23. So we work this. This is 11n. This would be minus 23, 33, 34. It's equal to 516. Add 34 to the other side. So we get 550. It's equal to 11n. So divide by 11. N is going to equal 50. Right? So n is going to equal 50. Alright, so let's take a look at B2 now. So now we need to find the sum, alright, for this value of n, which was 50. So the sum of the 50 terms. Now, n is 50, so I have 50 divided by 2 times, now I know the first term is negative 23, and I actually know the last term in this sequence, the 50th term they gave us earlier over here, right, was 516. So we can calculate this, put this in the calculator. Looks like our answer will be 12325. All right, let's take a look at this next example here. So we have this arithmetic sequence, right? And they want us to find the sum, or find an expression for the sum of n terms. So let's take a look at A here. So first of all, we know that this looks like it's got a common difference of 3. So the sum of some amount of terms, n, we would have n over 2, right? And then we would have parentheses 2 times the first term. In this case we know it's 2. I'll put a 2 there. I do know the first term. Plus n, which we don't know, minus 1 times d, which in this case which is 3. So I can simplify this. This will be 4 here plus 3n minus 3. So it looks like I'm going to end up with n over 2, right? Parentheses 3n plus 1. All right, so this expression here, right, represents the sum of some specific, right, amount of terms. Okay, let's take a look at part B. So part B says we're going to find the sum, find the value of n for which the sum is going to equal 1,365. So we have 1,365 is going to equal n over 2 times 3n plus 1, right? So what I'm going to do is I would just make this equal 0 and then graph it on a calculator and then find the x-intercept, right? So basically you want to make this equal 0, right? So it's going to 0 is equal to n over 2 times 3n plus 1 minus 1,365. So we're going to take this right here, we're going to graph it on the calculator, and then we're going to find the x-intercept, right? All right, so I'm going to graph this on the calculator. So I've got, so use x instead of n, so we've got x over 2, right, x over 2 times, we've got parentheses, 3x plus 1, and then we have minus 1,365. So we graph this, and then typically you're going to have to zoom out maybe a few times just to find the x-intercept. So here's our x-intercept, okay? So we need to find this x-intercept, the 0, so we end up with 30, right? So we know over here n is going to equal 30. Now I know n can't be negative, right? So that's why I kind of ignored the other x-intercept in our graph.